So, welcome to session 2. Last session we introduced to Python and introduced Colab and PyCharm, and then we wrapped up with our first few programs. Today we are going to move on to variables, data types, and operators. Without further delay, let's move on. So quiz 8 is what we're trying to do, and the Google Meet abruptly stopped after an hour. So the answer to this question, the two things every computer can do are perform calculations and remember results. And then quiz 9, what type of value is returned by the following function? Input, enter a number. I repeatedly emphasize this point that every time we try to give some value to the computer using input function, value will be a string data type. So that's the answer for this. And then the last one was pop quiz number 10. What is returned by the following code? There are two print statements here. By default, every print statement will start on a new line. So that will be the output. So there were two assignments. I'm going to quickly go over that. Assume that the address of the White House is as follows. Write a program that prints the address as shown above in 2 lines. This is how my solution looks like. What I'm doing here, if you see, is skip character with n, that is /n, and by doing that, the rest of the text will go to the next line. Assignment number 2, user was supposed to enter or provide his name, and then the computer would echo back with hello there and the name back to the user. And here's the code for that. Next, we will quickly learn about some programming approaches in Python. There are multiple programming approaches in Python. Procedural approach means the code is executed from top to bottom, left to right. Functional approach means the code is broken down into multiple pieces, also called modules, and each module may be worked on by a different developer or person, and then all of those are put together to achieve a common goal. And object-oriented means there are things that may exist in real life that we want to model in our code as a template that are called classes, and then those templates are used to create actual objects that are called instances. And we will cover functional approach in more details, I think, in session 6 or 7, and then object-oriented approach in session 9 and 10. We are starting with procedural approach. But we want to cover functional approach quickly in this session because we will come across multiple built-in functions in Python that are provided by default. So what are functions? Functions is a reusable block of code that executes a certain functionality only when it is executed. Like print function, it only prints when we call the print function. Another example was the input function. It only takes our user input when we explicitly make that call to that input function. But where do these come from? Where do functions come from? In programming language, certain functions are built in functions like print statement and input statement that we have already encountered. Other functions are included with new modules or packages that we import, functions that we can create on our own, also called our user-defined functions. And then once we create classes, they will have their methods. Those are also some form of functions. The main piece I want you to focus right now is the figure here. Functions basically act like a black box, and there may be 0 or more inputs. Those are called arguments or parameters, but essentially there are inputs, and based on that inputs, the function will behave certain way and give you some output. There may be also 0 or more outputs. When I say function, what I want you to think about it is like a black box that is already built that we can readily use and repeatedly use to make our life easy. I'm going to show you how you can save this into your Google Drive, and this will save as a copy into your drive. And this is what we're going to cover today. Once you open that link, if this is minimized, you can click on the maximize and you will see that menu here, file, and save a copy in drive. That way it will go to your own Google Drive. Once in your Google Drive, when you right click, you can create Google Colab Notebook. If you right click and do not see this menu option in your right click, then save this file into your Google Drive, save a copy in drive, and then once you do that, that option will come into your Google Drive menu. So after that, every time you want a new notebook, you can just click on new, more, and Google Colab. And that way you can create a new Colab notebook of your own. So by now, all of you have a copy of this material that we are going to go over today. If I expand this, it's a bunch of things in there. My intention is to try to cover those materials. So let's switch over and present to you what are the data types. So if you see this picture, the red blocks are immutable data types. That means those types are data where individual elements cannot be changed. And if you look at the green unlocked icons, those indicate that those data types are mutable data types. That means there may be one or more elements within that data type, and I can make changes individually in those elements. What I mean by that, you will come to realize when we talk about lists later on. Let's now first focus on numerical data types. Integers, decimals, and complex numbers are obvious ones, and then the Boolean data types are also subtype of integers. Booleans basically means true or false. Those are the only two types of Booleans. Integer means negative number, 0, or positive number that do not have decimal points. And then the float means those numbers that also come with decimal points. In this tutorial, we will not go over complex, but those are also possible in Python. Text or strings, we have looked at those from the beginning in the last session as well. And then there are collections, including lists, tuples, dictionaries, sets. There's also range data type or collection that we will also quickly go over today. And then binary, those are bits or bytes. We will also not cover those in this training. And lastly, there is none. It means absence of any data, and none is the only data inside non-data type. It only has one data in it. The value will be none. So when naming a variable, the valid characters for identifiers are uppercase and lowercase letters A through Z, the underscore character, and numbers 0 to 9, except for the first one. So we cannot name our variables starting from a number, but we can start with an underscore or a lowercase and uppercase letters, and spaces are not allowed in between. So I want to quickly switch over to built-in functions. When we install Python, these functions are available for us to use. We will go over some of these in today's session. Then I also want you to read through the naming convention, PEP8 style guide for Python. It defines how we can name things and how we can write our code, what is the best practice to write our code. Basically, it tells you how you should write your code so that others can understand and you can understand when you come back 5 years down the road. There is also keywords that are reserved in Python already that we cannot use when we name variables. For example, we cannot name our variables true, because that's a reserved keyword in Python. Keywords that you're seeing here are reserved keywords that we cannot use exactly to match our variable names when we define a new variable. So in Python, there are multiple types of operators. First, and the basic one is arithmetic operator, which includes plus, minus, multiply, divide, modulo operation. This is the floor operation. And then this is the exponent, the power, like 2 to the power 3 exponents, basically. And then assignment operation, we have seen this equal to sign at the end of last session. To create a new variable, we defined variable using this equal to sign. Do not confuse that with this double equal to sign, which is used for comparison. I will also show this in an example later on. But interestingly, this assignment equal to sign and this arithmetic plus, minus, whatever, all these signs can be combined together to create a single statement rather than multiple statements, and that is common way to do increment or decrement in programming language. We will see some examples.
Hey Sean, what is in the arithmetic, what is the double slash? What is that thing?
This is floor division. For example, you do 10 by 3, you usually will get 3 point something, right? But when you do that is when you do this division. But when you do this division, it will only give you the integer value 3.
Oh, okay.
Without decimals.
Okay, gotcha. Without decimals, okay.
Yeah, and sometimes in one program this will be very useful. I will give you project to do at the end of, I think, next session or after that. That will probably have to use, or better to use, this division. Okay, so moving on to comparison, there is double equal to, which compares the left side is equal to right side or not. Then there is not equal to, which is comparing the opposite here. Whether these two variables on the left and right are not equal to, then it becomes true. There's greater than or less than, greater than or equal to, and less than or equal to. But these are pretty straightforward to understand. Logical operators are and, or not. Moving on to identity. Okay, we will also do some example here. Membership in or not in is used to check whether some data is part of a bigger collection or not. Like if I have a string, I want to check if there is a character L in that string or not. Then we will most likely use in or not in. Bitwise operators are also there, but we will not cover those in our tutorial. So these are all the operators that are there. For so each operators can be combined with each other in making an expression or an statement. But then when you do that, you have to take care of the order of precedence. And this link here gives you that. So this is the order of precedence that is also part of the documentation that was in the link that I sent you. So look at this table. It tells you that the brackets are to be done first. Just like in our natural mathematics, the way we do math, whatever is in the bracket are taken care of first. And then index numbers are taken care of first. I will teach you index today. And then exponents, then there are multiplication, division, floor division. This was your question. And the remainder operators. And then there are plus and minus. Memberships and comparison comes after that. And then not and or comes all the way down. So let's switch gear and try to do some work, actual coding work, okay? So at the top of this Colab notebook, I have provided you my YouTube channel. That's where you will find a lot of materials. If you get confused, you can go there and find the answers, or just shoot me a message and I will answer that for you. So comments in Python. I gave you a brief overview. This is the way we comment every line. So if we want to comment a line, we will put this hash mark, and that whatever follows after that hash mark will be ignored when we execute the Python code. That is the comment for you, the user, to bring the clarity into your code and bring some meaning into what you're doing or why you're doing something, right? This hash again will only comment one line at a time, but there are multiple ways to multi-line comments, or how to do multi-line comments. You can do 3 double quotes open and close, or 3 single quotes open and close, and put any text in between, and anything that's in between will be treated as comments in Python. So when I run this, there is no output because everything is comment. Make sense? But when I run this, all of these are comments, so those will be ignored, and only print high will be executed, and the output is like that. Same thing with this. Notice how I have single quote here and double quote here doing the same thing in Python. So those are equivalent in Python, but not in other languages. So now let's move to literals and data types. Literals basically just means values. So if you look here in this example, there are a bunch of comments, and then there are 3 print statements. I'm printing 2, the string, 2, this is an integer, and 2, again, this is a float. So I'm printing same value, but in different data format or different data types. And by defining the value or exact syntax, I'm providing Python on how I want each value to be treated, like what data types I want them to be. Okay. The distinction between these data is very important, and boundary between these types of number is very strict. The characteristics of the literal which determine the kind, range, and applications is called the types. So every time I'm saying data type, that's what I mean. There are things that certain data can do, or certain data types can do, and certain others cannot. And when you are developing a new program, understanding the underlying concepts of these data types is of utmost importance, because once you start building and then you realize this is the wrong data type that I chose, then you have to go back and start from the scratch, which is always not good. So from the start, your foundation should be understanding, when you learn any new language, including Python, what are the data types and the operators I have at my disposal with this programming language. That is why I'm spending this whole entire 1 hour session trying to teach you data types and operators. Variables are just symbolic name that I want something to be stored and referred with that name. Okay, so like here, when I am saying something equal to some value, what happens in Python is this value on the right will be assigned to a box that is named with this name. Let me repeat that again. So whatever is on the right side of that equal to sign will be captured, and a box will be created. The box will have the name of whatever I define on the left side, but the value inside the box will be this value from the right side. I will show this on a visualization and this will be more clearer. So let's go to
So basically,
Python tutor. Yes, go ahead.
so if you go back to the previous screen.
Yeah.
Yeah. So what you have done here is you have a variable called max connections, and then you have assigned a value to
Yes.
it.
Yes, exactly.
Yeah. Okay.
So I want something to be also understood here. Python does not have any constants defined by default. And when we do all uppercase letters, that means I am understanding this particular variable to be a constant. I do not want to change that later on. By convention, everybody else doing same Python code will understand this because they will see everything is in uppercase letter. You can still change this Python because Python doesn't inherently have any constant values. You can still modify this, but by defining this as uppercase letters, I am notifying myself as well as other people who see my code and giving them my intention that this is supposed to be a constant. Do not change them.
Oh, okay.
Okay, let me quickly show this on Python tutor. So this is one of the link that I also provided in Discord. This is a very useful link if you get confused with some code down the road while we are learning or even after. This is a very useful code to do by visualization. Select Python from here. It also does some other languages, but since we are focusing on Python, that's what we're going to do. Edit the code, change everything here, and I'm going to put that here, right? And I just want to show you what happens, just to understand how Python creates variables. And hit this visualize execution, and it goes to it will show you the red is the one that will be executed next. It shows you the green is the one that just executed, but since we only have one line, we don't have a green mark here, and we only have step 1 of 1 because there's only one statement that we are executing. Okay, make sense? So if I do next, watch what happens here. There's a frame and there's objects. I'm clicking next. In the global frame, it creates a container box to store some value in the memory. Okay, that box has some address, but to access that address, I'm using, instead of using address number, I'm using another reference value called the variable name. Let me repeat that again. When I do this statement, this is a assignment statement. When I do that, it creates a container box to store that value from the right side, which is 5000. So container has that value, but to access that container, I'm using this reference, which is called the variable name. Okay, and if you did not notice by far, Python does not explicitly need user to provide what type of data type this is. For example, if I were doing Java, I would say int max connection equals to 5000 or float max connection equals to 5000. But Python does not need that, and it automatically detects what type of data should be this based on the data that I enter on the right side. So this is called dynamically typed programming because it dynamically determines my variable type or data types of this variable based on what data type I have assigned on the right side.
So if you put that 5000 within the inverted commas, then it would be a character, correct?
Yes, it will be a string. Yes.
String, yes. Okay.
So we will see that later down here. A bit on assignment and object creation. So here I am doing multiple assignment. This is called multiple assignment. A and B are separated by comma, and because there are two variables on the left, A and B, now I need to provide two variables or two values on the right. So A will get 2, B will be assigned 3, and then I have C and D both assigned 256, same value. Okay, and I want to print ABC. So let's see. So print A gives me 2 from here, print B gives me 3 from here, and then print C gives me 256 from here. Make sense? So that is the multiple assignment. There is also a shortcut assignment to switch two
Yeah,
variables.
hold on a second, son.
Yeah.
Yeah. So A comma B equals
2, 3.
2, 3.
Yep.
So what I understand that B equals 3. B has a value that is 2, right?
A has value 2.
So
A is in the front, so 2 is in the front.
Okay. Got it. So okay, got it.
Whatever is in the front will get the value from the front. Whatever is in the back will get the value from the back.
Right. Okay.
And then I want to show you this. Remember, A and B are 2 and 3. So this time I want to do A, B equals to B comma A. So what do you think will happen here? And let me just copy that. Print A and print B. So what do you see? Remember, A and B were 2 and 3. Now after this switching, I'm switching both at the same statement, one statement, and I'm switching both the values for both variables. So now they become 2 and 3.
The first one and the second one are two different programs, right?
Yeah, by default, Colab remembers A and B, the value for this variable A and B from this cell, and carries over to this cell. And that value is carried over to this cell. But now I'm switching them over. So now A becomes 3 and B becomes 2.
So it's only Colab or is?
Yeah, only Colab. This is advantage of Colab, but also disadvantage of Colab if you don't know how to use it. All right, so next we will see ID function. That's one of the built-in function here. If you look at ID, this is one of the built-in function. So what is ID? ID is identification of the memory where that thing was stored. So remember this storage, this container box, we are accessing using this reference, but it has certain address to that memory location, right? We don't know the address location, we just know the variable reference. And ID will give us that memory location. So remember, we still have D and C and D from here. So that's the value we are going to use and execute this statement. So here I'm separating two values. I'm printing two values here, right? I'm separating them with a new line character. So that /n again, remember from the last time we saw that? So print ID of D and ID of C. And when I execute that, you will see two exactly same ID. So what is this telling us? This is telling us that when we created C and D variable with 256 values, same values in them, Python does some sort of memory management and notices that, hey, C is also assigned 256, D is also assigned 256. Now do I have to create two different locations and store the same value? Python does that determination in the backend automatically and assigns same address location to those values as long as they are under 256. Okay, so here I have written down this note. Here C and D are separate assigned to integer objects having values 256, but in this case ID of one and ID of the second one are identical because those values happen to be under 256. But now in this example, if they are, what if they are under more than 256? So variable 1 and variable 2 are both assigned 257. This is called chain assignment again, new type of assignments. Remember, we had multiple assignment and then switch assignment. Now we see chain assignment. So in the last example, C and D were 256. Now variable 1, variable 2 both are 257. Okay, so printing variable 1.
Yeah. So the ID.
Yeah.
How is it useful in Python? Or
yes, very good question. So when do we use ID? We use ID to determine if the two objects are same or not. So for example, here variable 1, variable 2 have the same value, right? And earlier
right.
we saw they 256 C and D also have same value. Now here we are saying they both are having same ID, so those are stored in the same location in Python memory by Python interpreter. And ID is how we verify that. Like D has same ID as C and D also has same value as C. So D and C are exactly the same. So here you see variable 1, variable 2, 257, both variable 1 and variable 2 will give you what? 257, right?
Right.
See that? Both will give you 257. But again, the is operator, remember the identity operator, same thing or not? They are same thing because they have two same values and same identity. Another example of how assignment and object creation work. So here a equals to 300 and b equals to a. So what will be the value of a?
Same. 300, yeah.
And then ID?
ID would be the same.
So 300 and class is integer. So both are integer type. 300 is integer. So both have 300 values. Both have same class, integer type, and same address. So after the assignment b equals to a and b both point to the same object. So what do you think the code will print after this? From here, remember a was 300, now b was a, b was equal to a, so also 300. Now we change b equals to 400. So variable b is now assigned a different data of different data type. Maybe that data type is different, maybe not. We will change the value of a. Will this change the value of a?
Yeah, ID will be different too.
ID will be different,
Yeah.
value will be different. And if
Yeah.
we also change the data type, the class will also be different here. So let's say 400.0 value are equivalent but different, right? 300 and 400.0. Now this is a float data type. So what happened to this b equals to 300 when we changed to b equals to 400.0? We had integer, now we have floating point with the same variable reference. What happened to the old value?
It got replaced with that replaced.
Yes, and in Python or in programming language terms, that is called garbage collection. So lifetime of a variable object is until we use them. After we use them, they are done. Those will go to garbage. Python manages that memory internally by itself automatically.
So the new value will remain.
Yes.
The other one goes to the garbage.
Yes.
Like for example, 300 or whatever we assign.
Yeah.
Okay.
So non-literal is nothing but just non-value. A equals to none, and if we do print a, none is the value, and then class type is non-type. There's nothing much interesting here. We will only use this for certain scenarios. We will come across those maybe in future sessions. Booleans are just true and false values. True and false. We can compare true and false. Remember once upon a time I told you true and false, the booleans are subclasses of integers, and those two boolean values are pi false and pi true in Python. Here's the documentation link if you want to read more. But since they are integer values, we can also compare true and false. So true is greater than false or not, or true is smaller than false or not. So print true will give us true, print false will give us false. True is greater than false because true value has integer value of 1, and false has an integer value of 0. So 1 is greater than 0, that's why we get a true here, and likewise we get false here. Booleans are subclass of integer. Again, print integer value of true and integer value of false, and we can see that, and then we can print true plus 2. Now since true is 1, we get 1 here. False doesn't have a value, so we get 0, and then 1 plus 2 gives us 3. Clear? A lot of people, after even 3-4 years of programming, they don't even realize that true and false are subtypes of integers, and they can compare and use that to their advantage. So let's talk about integers and floating points. Oh, those are not very interesting. Integers are just negative, positive, or 0 numbers without decimals, as I told you earlier. Floating numbers are those numbers with some decimal values, even if those are dot or decimal 0.0 values or point nothing values.
Row number 8. So G equals.
Here.
What does that say?
Exponent.
What is that?
3 to the power 2.
Oh, okay, gotcha.
Yeah, some language has this character, 3 to the power 2. That is not here in Python. So we use double multiplication sign to indicate power. And this is scientific notation. Whatever comes after e, this has to be an integer. But then let's see, print I and print type of I and see what we get. So we get a float here. Okay, so by default, scientific notation and division will give us floating values after the calculation, even if we purely use integers in the calculation. Integers have unlimited precision, so that means you can define whatever integer you want as big as you want. Floating numbers have some precision, 64-bit double precision values in Python. Some other ways to define integers: if you have large values, you can separate them by underscore after every 3 digits and still get same outcome. So when I defined, I use underscore for readability of my own advantage, but Python will read them as any other integer without underscore. Interestingly, Python also uses or allows us to use calculations within print statement. If you did not notice with the assignment that I gave you after the last session, there was concatenation assignment or addition of strings together. You could do that inside print statement. Here it will add this to and compare that with this value. Okay, what do you think this will give?
It gives him true and false, right?
True? Anybody saying false? All right, let's see. What is happening?
Yeah.
So in Python, or any programming language for that matter, floating points cannot be exactly precisely represented in binary numbers. Remember last session I told you everything is stored in the memory as ones and zeros, so that thing comes to bite us now. Why is that? Like 0.3 cannot be exactly represented in binary numbers, so the left side and the right side do not match here, and that's why we get the false, and that is called floating point rounding errors. And every programming language will have this inherently because computers have that problem. Of course, we do 1 plus 1 and 1 plus 2, we get 2 plus 3. Nothing new there. So let's talk about strings now. We know strings are anything that comes under a pair of double quote or single quote, including nothing in between. So this is an empty string, and that is a valid way to define a string in Python. And here I'm using what? See this double quote and then other double quote and double quote. So what is happening? This is confusing, right? I'm using backslash as a skip character again. So whatever immediately comes after this is ignored and printed as such. Without this, there will be error. See that? But since I'm using backslash, the interpreter will just print exactly what is there without issue. So that's one way to avoid syntax. Another is to mix and match single quote and double quote, like that. Okay. So here you see two different types of concatenation. One is using comma and one is using plus in between those two strings. Python will treat both equally. The only difference is there will be an added space bar after the comma, but not after the plus. So keep that in mind. So continuing here, this is something called f string. So f and then single quote or double quote, and then I'm defining my string inside that f parameter. So something called format string or f string for short, and that is handled by Python as well. I like this example, this one. So I'm defining 3 different variables here. The first 2 are purely string, the last is integer, and I'm printing them 3 different ways. First is using string concatenation, separated by commas, if you recall from the last exercise that we did here. The second is something called format method. That is another built-in method. So format is here. Okay, so that built-in method is being used here, And what I'm doing is curly brackets, curly brackets, curly brackets defined where I want some things to be replaced, and replaced, what is to be replaced with comes inside that format method as parameters or input values. So every time print will check these empty curly brackets and assign that value there. So that's called a string format method. And this is the fstring method. We saw that earlier here. Fstring also uses curly brackets, but then nice thing is instead of defining dot format method and defining parameters inside there, I will define that within the fstring itself. So this is more neat version, or I would say succinct, better version of the dot format method. And this is my favorite way to write any string. So let's run this and see all three outputs are exactly the same. No differences.
Quick question.
Yep.
Question. On line 5, print my text.
Yeah.
And then classes 1. Why are they white?
They are white because I'm using a variable here.
Oh, okay.
My text is defined here. My new text is defined here. And then classes is defined here. I'm doing class -1. Inside print, I'm doing all these calculations.
Okay, thanks.
Good question. So a few ways to round a floating number. I have a number here that is a floating number because it's a decimal number. I'm using round function, which is another built-in function. And then round takes two parameters, the value that I want to round and the number of decimal places that I want to round to. And all these other ways, including this fstring with .2f and then the %.2f, all those are doing the same thing, rounding this value to 2 decimal places. So instead of 93949, I will just get 94. Okay, these are useful methods when we work with string later on. Dot title will, so here the name has the value John Doe, all small letters, right? And the title will update this to show capital letters on the start. The upper will change everything to upper letter, and then lower will change everything to lowercase if there were any uppercase letters. Python also has built-in methods for strings that strip white spaces from the front or the end, or both. So remember, this is our favorite language, Python, with a blank space in the front and blank space in the back. And with rstrip, it strips the right side, removes that extra space. Lstrip removes the front space in the beginning. And if we just do a strip, it will strip from both ends. What is happening? No output. We don't have a print statement. That's why there's no output here. Like I said earlier, you will get this whole Colab notebook from that link that I gave you, so you can play around with any portion of this code. That will be your local version to make changes and play around. Of course, a string will have numerous other methods. We cannot cover everything here, but these are some common ones that you will need. And if you want to go and learn other methods that I did not cover here, here's the link to go and check those out. Next up is range function. Range is also a type of collection data type, and when you do range 10, basically it will create a bunch of numbers starting from 0 ending before 10. Okay, so keep that in mind. 10 is not included when you do range 10. It starts from 0 and ends with 9, increasing one number at a time. Here I'm defining a range, and then this is typecasting. So the range is then converted to a list, and I'm printing that list here. So what does the list look like? It just looks like a bunch of numbers or elements separated by commas, putting together inside square brackets. So list 1 and list 2 are exactly the same. What does that tell you? That tells you that range 10 and range 0, 10 are exactly the same. So by default, if you don't have two numbers in the range function, it will by default start with 0. and by default increase by number plus 1 at a time. So 0, 1, 2, 3, 4 all the way to 9. 10 is not included, again keep that in mind. Now print list 1.
So
Yeah.
if you Shan, if you put the range like 20,
Yeah,
what happens?
it prints all the way to 19.
19, right? Okay, that's fine.
There.
Yeah.
So is list 1 is same as list 2? Of course not, because we changed here. Let's bring that to 10. Now what if we run this? That is false. And why is that? So let's see, go back to visualization. Remember this website, pythontutor.com? I want to paste that code here, and then I want to try this as well. So let's see what happens. Remember this box that I was saying, frames, the global frame? When I do next, it will create a list. See that? So that is how it's stored in the memory. This is a list data type. This object itself is a list data type. It has a bunch of elements inside each index numbers. So these 0 to 9 are the index numbers, and these 0 to 9 are the actual values inside those index numbers. I will also teach you about index a little bit in a slide. But remember, those are the index value starts with 0, and it doesn't always have to be same as the value that are stored in those containers. In the global frame, I have list 1. List has 10 elements in it. Click next. Remember this, the green one is already executed. We are ready to execute line 2, the red one. So it is nothing but printing that same values on the output. Now it moves to line 3. When we do next, another list is created exactly like the previous list. So list 1 and list 2 are not same. You see this in the memory, how it is stored? And that is exactly why when we do print list 1 is list 2, it will give false. I hope that visualization makes you understand more clearly. So print 9 in list 2. This is membership operator. Do you remember that membership operator back here? Membership in, not in, whether some object is member of another object or not. Here we are trying to see if 9 is in list 2 or not. When we print, it will give us true because there is 9 in this list, or list 2. What about list 1 in list 2?
The values that are in list 1 are in 2.
Yeah, but is list 1 in list 2?
False.
False. Why?
False. The same thing, right? The mutable scenario.
Sorry, what? Explain it again.
The mutable scenario.
Kind of. Let's go back to this visualization. Do you think one list is inside another list? No, right? Those are two different objects. So one is not inside another. One is not a member of other. Those are two different objects pointing to different locations. So those are two separate entities. Not any part of one is not part of another.
That would be false.
So tuple is another data type, and tuples look similar to list, but they are separated by this regular bracket instead of square brackets. That's the major difference. We already used tuple, remember? When we switched A and B, A comma B equals to B comma A,
Yeah.
those were tuples. So even if we don't provide bracket and separate two different numbers or objects with comma, that will by default become a tuple. So here I'm, okay, range 15, minus 15, 3 and 2. I'll tell you what each of these numbers are doing, but range is giving us some collection, right? And then this is again typecasting that range into tuple data type. Okay, so let's understand what these indexes are. So index can be inside range. You saw index can be 1, 2 or 3 different values. So when we only do one value, it will start with 0 by default, increment by 1 by default, and then end before this number by default. when we have two number, this is the starting index or starting value and ending value, and the step is +1 by default. And then when we have three numbers, this is the starting value, ending value, and the step. Instead of +1 by default, now we do +2 by forcing as third parameter here. Make sense? So we are starting -15, +2 gives us -3, +2 gives us -11. We are going all the way to 1. 3 is not included. Again, why? Because that is the ending. Remember, the ending is never included in range. So it goes all the way to 2, not 3. And since +2 goes from 1 to 3, we do not see 2, or we do not see 3. It ends at 1. Hope that makes sense. Again, tuple, because we explicitly typecasted a tuple, that's why we are seeing this regular bracket, not the square bracket or curly bracket. Anybody confused?
Totally confused, yes.
Okay, so where? Range?
The tuple thing, I don't understand the value, the printed value.
Okay, remember this data types? We have list, tuple, dictionary, sets. Yeah?
Right.
Tuple is immutable data type, list is mutable. The only difference is that one is mutable, another is immutable, and then list is indicated with a square bracket, tuple is indicated with the regular bracket. Okay, so this was list, and if we change that to a tuple, it becomes same thing with regular bracket.
Okay.
So let's say tuple here, okay, and see the difference. See that?
Okay. Yeah.
So because this is tuple, this is immutable. We cannot change elements in it. So we cannot change that to be 10 later on. But since this is a list, which is a mutable data type, we can change each element one at a time, or multiple elements. We can add elements to it, or whatever change we want to make, because of this being a list data type.
So what is a mutable data type and a non-mutable data type? What is the difference?
Okay, good question. So here, let me say, okay, you know this is list 1, right? When I did list
Right.
1, this was coming out.
Yeah.
So remember the index number starts with 0. Actually, let me teach you about index numbers. This is showing string index, right? So indexing is same whether it's in string or list or anything. It starts with 0 and ends with whatever number is ending. So this H, E, L, L, O, all of these are elements within this string. So my string was hello world. H is an element, E is an element, L, L, A, O, this comma, this space, everything is individual elements.
You're right.
And to get to H, we need to index using index value 0.
Right. Right.
Index value 1 for E, index value 2 for L. Similarly, all the way to 12 for this exclamation mark. Okay?
Right.
Python also has negative indexes. That goes from the back. And it starts with -1 and decrements one at a time. So it goes all the way, at the front would be -13. Why is this useful? Because some strings we don't know where it ends. So instead of going positive to the end, which we don't know what the value is, we can start with negative index for that same value or the same element and get to the end automatically. Make sense?
Yeah.
So hello world index value 12 is this exclamation. Hello world index value -1 is also the same exclamation. Okay, why I was showing you this? Because that index comes back here, so I'm going to use that here. So I have list 1 and index value. Remember this, these are also index values. So let's say index value 9 equals to 8, and then I also want to do the same print list 1. So what happened here? I had 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. I changed this last element given by index number 9 to be a new value 8. So now I have 0, 1, 2, 3, 4, 5, 6, 7, 8 and 8. The 9 has been replaced with 8 with this line. Make sense? Anybody confused?
Yeah, it's good. So
what does that mean is, because I'm changing individual element from this whole list, that tells me list is a mutable data type. But can I do the same thing with this tuple? Let's try. So here list2, see, as soon as I do list2, it will give me underline here saying there's something wrong. So let's try to run that and see what you get. Type error. Tuple object does not support item assignment. That means tuple is immutable data type. I cannot change individual element inside a tuple. Now do you understand what is mutable and immutable?
not really.
Okay, so let me explain again. Earlier I was using list 1, which is this list, right? And I started
Right.
with ending value of 9. I changed that to 8. I was able to change that to 8.
Yeah.
And I got, instead of 8 and 9, I got 8 and 8.
Yes.
So
I understand that. Yes.
So that means this list data type is a mutable data type,
Meaning that you can change it.
meaning that I can change every element inside it.
Okay, got it.
But I cannot do the same thing with tuple. As soon as I do 2, it will already show me there's something wrong here. And it does
Okay.
not support item assignment.
Mm.
So
Okay.
I cannot change each individual item. I can redefine list 2 to be another tuple. Now I'm redefining list 2. And then print list 2.
Right.
That is okay,
Yeah,
right? So
got it.
this is a tuple.
Yeah.
But I cannot
Yeah.
change individual element inside that tuple and try to do that. That will give me error.
Okay. Yeah.
Set is another data type. Set will remove duplicates. That's the main difference. Okay. So here I'm using range. So this goes from 5, 6, 7, 8, 9. Stops before 10. So I get that. Set is indicated with this curly bracket. Okay.
Right.
So we have, what do we learn? We learned list, that is using square bracket. We learned tuple, that is using the regular bracket, and then we learned set, that is using curly brackets. Okay, so let's move on to simple arithmetic. We've done most of this so far, nothing much new here. 3 plus 2, 2 minus 3, 3 times 3, and 9 divided by 3. We know all of those. Again, remember division will by default give us floating number, so that's why we're seeing 3.0 instead of 3 here. Now integer 16 divided by 3, and we're converting that to integer with this typecasting and printing that, so we're getting 5. Similarly, when we use floor division, 16 by 3 will only give us 5 and not give us decimal number. So hopefully that answers your earlier question.
Yeah.
So here's the exponent or power. 3 to the power 2 will give us 9. And then here is modulo operation. This is what is the remainder after the division. Okay, so 10 divided by 3 will give you 3.33, and so basically 3 times 3 is 9, and then there is a remainder 1. So that modulo operation gives you the remainder that is remaining after you do the division. Make sense?
Yeah, but why would you need that modular?
Good question, good question. So write a program that gives you true when the number is even.
Okay. Okay. Yeah.
So let's say a equals to 2 and print even. When do I print even? Only when a is 2, right? So right now it's printing even all the time. So that's not what I want. I'm going into if statement, that is next class, but I'm giving you a hint because you asked me the question, okay? So if a modulo 2 equal to 0, then I do that print. So what does this tell you? I am dividing a with 2 and finding a remainder. If that remainder is equal to 0, only then I know this is even number. Make sense? What if this was 3? Do I get that? Print. I will not, because this remainder will be 1. This side will be 1, this side will be 0. The comparison is false, and therefore we do not see this print. I would like to save that for next class, so let's not get confused too much. Remember, I told you we can combine. So I'm defining a equals to 5. Now I'm doing that 5 plus 2 and assigning the value back to 5. When I print a, I will get 7. Does anybody want me to repeat that?
Yes, please.
This
So
operation,
you're
this operation
so you're
is,
assigning a
okay, let me explain.
Uh-huh.
This operation is same as saying a equal to a plus 2. Okay, so it evaluates a plus 2 first. What was a? 5. So 5 plus 2 is evaluated, which is 7. Now that 7 is stored back into a,
Okay.
and then print a gives us 7.
Oh, okay.
So instead of doing this longer one, this is the short way to do it. This is also available in other programming languages as well. So here are comparators, pretty much straightforward. If I define a equals to 5, then a should be equal to 5. This will give us true. A is not equal to 5 will give us false. A is greater than 5 will also give us false, because 5 is not greater than 5. This will also likewise give us false, and these two will give us false, because it is checking whether they are greater than or equal to, or less than or equal to. Make sense? So I think that I will wrap up for today at this point, working with list and then working with dictionary. So we will also do that in next session and then continue the conditional statements.